Okay, these questions where you're drawing graphs tend to be on the non-calculator paper. So when you are having to work out missing values, it's always worth your while testing first of all to make sure that you are working things out correctly by taking an x value that you already know the y value for, just so that you can be confident that you're doing it correctly. So with this first question, we've got a table showing some of the values of y equals x squared plus x for values of x from -3 to 2. And we've got one missing, and it's a negative one. If you're going to go wrong, it's more likely you'll go wrong with a negative one. So let's take -3 and make sure that we can get 6 out of our formula. Okay, so test when x is -3, y will be -3 squared plus -3. Now -3 squared is minus times a minus is a plus 9, and you're going to be taking 3 off it, which is 9 take away 3, 6. So I know how to do it. So when x is -1, y will be -1 squared plus -1. So -1 times -1 is +1, and plus times a minus is a -1. So I got 1 take away 1 is 0. So the missing value there is 0. If that was on a calculator paper, you need to be careful when you are working out a value like -3 squared. Okay, if you just put into your calculator -3, do that again. This button here is a subtract button. So what you don't do is subtract 3 squared, okay, because you get the wrong answer out, -9. Let's try and get this light a bit better. So that's wrong. The minus button is this one here, okay, the negative button there. So if you did -3 squared, you still come up with the wrong answer. Okay, the clue is the brackets around the negative button. In order to correctly put in -3 squared, you have to start with a negative, the open bracket, then -3, close bracket, now square it, and you get the 9. Okay, so it's really important, whether it's on a calculator or a non-calculator paper, when you're dealing with negative numbers, that you use a test point just to make sure you're doing the right thing. Okay, back to the graph then. So what we're doing now is we're plotting these points. So when x is -3, y is 6. So when x is minus or -3, y is +6. And put a clear cross so that when we join them up, the examiner can still see where the points are. X -2, y 2. -1, 0. 0, 0. 1, 2, and 2, 6. Okay? Now if you've got a function y equals x squared something, where the highest power is a squared, your graph is always either going to look like that or like that. Okay, so you can see there that looks as if it's going to give us a smiley sort of graph. You join the points freehand, not with a ruler, and it's usually easier to turn your graph so that your wrist is on the inside of the curve. I'm left-handed, so I've got to turn it that way. If you're right-handed, you would turn it the other way. And you join your dots. Okay, and it's important that just because we've measured, we've got 0 there and 0 there, there are other things going on in between -1 and 0, which will probably take it below. So you don't cut straight across. What you're doing is taking a little bit below and then back up the other side like that. So the examiner can see it's not a perfect curve. I've got a little wobble there, but I'm going through all the points. I've kept the shape of the curve going below those 2 points and back up the other side. And I'm going to get full marks for that. So the second question, again, it's different. It's an x squared graph, so it's still going to be one of those shapes there. But the function this time, the formula is 5 take x squared. So we're going to do another test point. We're going to take -2 to make sure I can get 1 out of it. So x is minus or -2. Y will be 5 take -2 squared. Okay? -2 times -2 is +2, +4, sorry. To give me that. And then I've got 2 signs which are different, which means I can replace them with a negative. If the signs are different, then the answer is negative. So that's going to be 5 take away 4, which is 1, and I know that that's right. If you were allowed to use your calculator, then what you would be typing into your calculator would be 5 take open bracket -2 close bracket squared. Okay, that's a subtraction, that's a negative, so they're different. Press equals and 1 comes out. So I know that I'm pressing the right buttons on my calculator to do that. Okay, so it's really important you use that test point. I need -1, so when x is -1, y will be 5 take -1 squared, which is 5 take +1, which is 5 take 1, which is 4. Okay? If you want to do that in your calculator, just to be sure, on your calculator you're going to be putting in 5 subtract open bracket -1 close bracket squared equals 4. Okay, so you've now got all your points. You're going to put them on your graph. With this graph, they haven't put the scale on for you. What's crucial is you put the scale on to maximize use of the space you've got. It's fairly obvious going across that it's going to go across -2, -1, 0, 1, 2, 3, 4. But what about vertical? Vertically, the most positive value you've got is 5. And the most negative value you've got is 11. So if you were going down in ones, you go -1, -2, -3, -4. That isn't going to help. If you go down in twos, you have 2, 4, 6, 8. That's not going to help. So what you need to do is go 2, 4, 6, 8, 10, 12, 2, 4, 6. Right. So when x is -2, y is 1. So x is -2, it's going to be halfway between there and there. -1 is 4, 0 is 5, 1 is 4, 2 is 1, 3 is -4, 4 is -11. So those are your points. Again, turn so your wrist is on the inside of the curve. And there you go. Now with this one, we've got to draw a second line then. Okay, we need to draw the line y equals 2 on the graph paper. So y equals 2 is a line where every y coordinate on the line is 2. So there's the y coordinate 2. So it's going to be a horizontal line which goes through y equals 2. So if we write there y equals 2, then that's clear for the examiner what we were trying to achieve there. And write down the x values of the points where the two graphs intersect. So the graphs intersect there. So the x value is that value there, which is going to be minus 1.6. And it's also going to intersect there at 1.6. Okay, and those aren't always the same, it just happens to be they are with that particular question. Alright, question 3. This time it's a cubic graph, it's x to the power of 3, so it isn't going to be a smiley face. It's going to look a bit different from that. Again, we're dealing with negative numbers, so make sure choosing a test point we can get the right thing out. This time let's choose -2 as our starting point. Okay, so let's do this on the calculator. So it's x cubed, so open bracket, -2. Now cubed is that button there, and we want to add 3 to it, which is -5, which is what we want, so that's great. We now need -1, so x equals -1. In our expression there, we open bracket, -1, close bracket, x cubed button, add 3 equals 2. And then for 2, we don't need the brackets, but if we put them in, it'll keep it consistent. So it's 2 cubed, add 3 equals 11. If that was on a non-calculator paper, 2 cubed is 2 times 2 times 2. 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 2 cubed is 8, add 3 is 11. With the negative ones, -1 times -1 is +1, times another -1 makes -1, add 3. Let's write that out. -1 times -1 times -1. -1 times -1 is +1, times -1, plus times a minus is a minus, 1 times 1 is 1. So -1 cubed is -1, add 3 to it, and you've got 2. The -3 one, -3 times -3 times -3. Minus times a minus is a plus. 3 times 3 is 9. Nine times 3 is 27. Plus times a minus is minus. So we get -27. To the -27, we need to add 3. Minus 27, add 3 is -24. Okay, so that's how that would work if we weren't allowed to use the calculator. Right, So plotting these points now, what we have is x is -3, y is 24, x is -2, sorry, -3 is -24, -24 is down there, -2 is -5, -1 is 2, 0 is 3, 1 is 4, 2 is 11, and 3 is 30. Okay, so we need to join those dots together now, and we'll get a shape that looks like that. That's a typical cubic graph. All right. Question 4, just turn my phone off. Question 4. Now this one, we haven't got any work to do as far as calculating the values, so we just go straight to plotting them. So the first point is -2, 11, -2, 11, -1, 0, 0, -5, 1, -4, 2, +3, 3, 16, and 4, 35. So those are the points. Join them with a smooth curve. So that's what the graph looks like. So that's A, and then B, draw the line y equals 5. So that's where everywhere where the y coordinate is 5. It's going to be there. Y equals 5. And write down the x values of the points where your two graphs intersect. So that's going to be there, which is -1.4, and there, which is 2.1. And if your curve is slightly different, you'll still get the marks for correctly reading off your graph what those values are. Next one. Okay, so this time the equation is an x squared equation, 2x squared minus 5x take 8. So again, let's put a test point in. It's a positive value we've got to work out, so let's just check we can get minus 10 out if we put 2 in. So there's our equation, so it's going to be 2 open bracket instead of x 2 squared, take away 5 open bracket 2 close bracket, take away 8. So what's on the calculator screen is the same as that, except instead of an x I've got bracket and then the number 2. So hopefully when I press equals, minus 10 comes out. Yes, it does. So I know I'm going to use my calculator correctly. So I have to do the same again now, but 3. So it's going to be 2 open bracket 3 close bracket squared, take 5 open bracket 3 close bracket, take 8 equals -5. On the graph paper opposite, draw that graph. So I got -2, 10, minus 1, minus 1, 0, minus 8, got off the screen, is it? 1, minus 11, 2, minus 10, 3, minus 5, 4, plus 4. Join them up. Obviously in the exam you would be better off using a pencil than I am on the graph, but you want it to look something like that one. And you know, it doesn't have to be perfect. You show in there that you're trying to do the right thing. That doesn't look great, but that will give you the full marks for doing that particular part of the question. Right, and now for C, draw the line y equals 3. Well, we're getting used to that. Y equals 3 means you want a horizontal line going through 3. Y equals 3, and then you want to write down the x values of the points. So we need to read off that one, which is going to be minus 1.5, and this one, which is going to be 3.9. So minus 1.5 and 3.9. This is a new bit. Okay, we're into the sort of A grade part of the question really. Write down and simplify the equation in X whose solutions you found. Well, what you've done there is you've got the graph 2x squared minus 5x minus 8, and you're finding out when that's equal to the graph of y equals 3. So that's the equation whose values you found, and they want you to simplify it by bringing the 3 over. So you get 2x squared, take 5x, take x, that plus 3, you need a negative 3, equals 0. So that's it, as simple as it can go. That's the equation you have solved when you've read off those values there. Okay, but that's pretty high level stuff now. You're into the A star grade in answering that part of the question. Okay, question 6. It's an x squared graph, so it's going to be either a smiley or a sad smile. Let's get our calculator going again. Do the test. So here's our function, so it's going to be 2 open bracket negative 2 squared, take 5, and instead of the x, open bracket negative 2, take 3, and hopefully that will equal 15. Yes, it does. So I know that I'm putting it right correctly into my calculator. So repeat that now, but with negative 1. So it's going to be 2 bracket negative 1 squared, take 5 bracket negative 1, take 3 equals plus 4. Okay, so negative 2 up to 15. Negative 1 up to 4. 1, 2, 3, 4. What a horrible scale they're using here. Okay, what we've got here is that we're going from 0 to 5 in 1, 2, 3, 4 squares of the larger ones. So at 5 divided by 4, is 1.25. So each one of those is 1.25. And I want to go, where do I need to go? 4. So 4 lots of 1.25 is 5. So I need to do, hold on, get my head around this again. So there is 1.25. So each one of these little squares, which you can't really see on this paper, is 1, 2, 3, 4, 5. So that's 5 squares. 10, 20. So 5 divided by 20. So each little square is a quarter. So if each little square is a quarter and I need 4, then that means I've got to go up 8 squares. So that's 5, 6, 7, 8. That's not right. I need to go up 4. Each little square is a quarter. Each little square is a quarter, so 4 little squares is 1 unit. So 4 little squares is 1, so I've got to go up 16 squares. 5, 10, 15, 16 squares. That's horrible. Let me explain what I did there again. Each little square, there are 20 little squares to go from 0 to 5. Okay, so 20 little squares is 5. Okay, so 1 little square is 5 divided by 20, which is 0.25. So each little square is a quarter. I have go up 4. So 4 little squares equals 1. So 4 little squares is 1. So I need to go up 4. So I need to go up 4 lots of 4 little squares. 16 squares. 5, 10, 15, and 1 is 16. That's nasty scale. Then we've got 0 minus 3. So that's going to be 12 little squares. 5, 10, 11, 12. Then 1 is minus 6. 5, 1, 2, 3, 4, minus 6. 2 minus 5. 3, 0, and 4 is 9, which is going to be 4 down from 10. 1, 2, 3, 4. So eventually we get our points plotted. Now we draw the curve. Alright, so that was really horrible just because of the working out what the scale is. It's foul. So we've done A, we've done B. We're now on C. Draw the line y equals 3. The line y equals 3 is going to be 12 little squares. 5, 10, 12. That's 3. So it's going to be horizontal through there. Y equals 3. And write down the x values. So there's one of the intersections. That's going to be minus 0.8. And this one here is going to be 3.8. And this is the A star bit again. Write down the equation whose solutions are those. So those solutions are when that 2x squared minus 5x take 3 are equal to that 3. It's not asking you to simplify it, but we will anyway. 2x squared take 5x take 3, bring that across, it's goes from positive to negative. So we get 2x squared take 5x take 6 equals 0. Really horrible because of that scale. Question 7. Right, let's check this first of all then. So we've got 3x squared plus x take 5. Let's do it without the calculator in case. So let's pick the minus 3. So x is negative 3. Y will be 3 times negative 3 squared plus negative 3 take 5. Minus 3 times minus 3 is plus 9. 9 times 3 is 27. So that first bit there comes to 27. Minus times a minus is a plus. 3 times 3 is 9. 9 times 3 is 27. That, signs are different, becomes negative, becomes that. So we've got 27, take away 3 is 24, take away 5 is 19. So I know that it's right. Now I'm going to do minus 2. So x negative 2 minus 2 or negative 2 minus times a minus is a plus. 2 times 2 is 4. So that becomes plus 4. 4 times 3 is 12. That becomes take away 2, take away 5. So I got 12, take away 2 is 10, take away 5 is 5. If you were doing that on a calculator paper, let's just check. Let's do it first of all with the answer we know. 3 bracket minus 3 close bracket squared plus bracket minus 3 take 5 equals 19. So I know I'm going to do it right. 3 bracket minus 2 squared plus bracket minus 2 take 5 equals 5. Good. I'm confident that my values are right. Let's hope the scale's a bit nicer. Yes, it is. Okay, so we're going from 0 to 5 in 10 jumps, so each little square is a half. So minus 3 is 19, so it's going to be 2 down from 20. Minus 2 is 5. Minus 1 is 3. So that's going to be 4 down, 1, 2, 3, 4 from there. 0 is minus 5. 1 is minus 1. 2 is 9. And 3 is 25. Now I'm looking at that, and as I was plotting it I thought, hang on, something's wrong here. If you remember that this is an x squared, so I'm looking for that sort of graph or that sort of graph. That point there is wrong, because otherwise I'm not going to have my smooth curve. So what have I done wrong? Let's have a look. Minus 1 is negative 3. I've plotted it as positive. Okay, so that there is wrong. It should be there. Okay, so I'll just put a cross through it like that, and that looks now as if it's going to be right. So let's turn it upside down and do my graph. So quite clearly, if I'd have drawn the graph through that point, it wouldn't have been a smooth curve. So you can use that knowledge to say, hang on, that point's not right. Okay, C. can see a definite pattern developing with these questions now. The line y equals 11. Y equals 11 is going to be where the horizontal line where the y coordinate is 11. Draw it across your graph, put it in, and write down the x values where the two graphs intersect. So one is going to be minus 2.5, and this one is going to be 2.1. This question doesn't ask for the equation, but if it did, then you'd put 3x squared plus x, take 5 equals to 11, bring the 11 over and simplify it. And finally, one slightly different one again. This would certainly be at the far end of the paper. So the equation this time is 3x plus 10 over x. Okay, it's going to be on a calculator paper, so we'll just use a calculator for this one. Again, it's worth using a test point first. So probably on your calculator, we'd put this in as 3 bracket 3. Instead of x, we're going to put 3 plus, and then if we use the fraction button, it gives us 10 on top, and on the bottom we're going to want to put 3. Okay, so 3x plus 10 over x becomes 3 plus 10 over 3. Press equals and turn it into a decimal. 12.3333, little dot above it there, telling you that it's recurring. So that is the way I'm going to put in my other values. So first of all, 3 bracket 1 plus fraction button 10 over 1 equals 13. And then the same with this, 3 bracket 2 plus 10 over 2 equals 11. Then I can plot my points. X is 1, y is 13, so this is going up 12, so halfway is going to be 13. 2 is 11. 3 is 12.33, so we're only going to get this fairly approximate, 12.2. We've got there. 4 is 14.5. 2, 4, 6.5, and 5 is 17. Okay, so joining those up, don't know what's happening there. It's going to look like that. So we've drawn that graph between 1 and 5. So I've got another line to draw now, another graph to draw, which is y equals 27. Take 4x. Now because there's no power, that's going to be a straight line. So I need two different values in order to draw the line. If I put x as 0 in there, then y is going to be 27, take away, 4 lots of 0. 4 lots of 0 is 0, so it's 27. So when x is 0, y is 27. When x is 1, y will be 27, take away 4 times 1, which is 23. So when x is 1, it's going to be 23. Only need those two values to draw a straight line. So there's my line. And we want the coordinates of the point of intersection. So we want to know what the coordinates of that point there are. So reading down, it's going to be 3 point something. 3.4, and reading across is going to be 13. So that's the coordinates at the point of intersection. So most of those questions follow a very similar pattern. Hopefully you can get familiar with it and pick up some good marks.